Welcome to The Explainer. For what feels like forever, robots have been, well, a little clumsy, right? Really impressive in a lab, but kind of awkward out in the real world. But something just shifted. All of a sudden, we're seeing this incredible, almost overnight leap in what they can actually do. So today, we're going to break down what just happened.
For years, the only place you'd really see a robot was bolted to a factory floor, just doing the same exact thing over and over. And anytime someone tried to bring them out into our messy world, they just struggled with the simplest stuff. But the robots we're seeing now, totally different. They can handle tricky things like soft, unpredictable laundry. And yeah, some of them have dance moves that honestly put me to shame. Okay, let's really get into it.
So what's the deal, you might be thinking? Okay, there must have been some huge breakthrough in motors or new materials, right? But here's the thing. The hardware, the actual physical body of the robot, it hasn't really changed that much. So if it's not the body, then where did this leap forward come from? Well, the answer isn't in the muscle. It's in the mind. It's all about the robot's brain.
And to get what's happening, we first have to talk about an AI that you probably already use. It's called a vision language model, or a VLM. Think about something like ChatGPT with vision. The tech that lets you snap a picture of your fridge and the AI tells you what you can cook for dinner. That's a VLM. It can see the world, it understands what you're asking, and it gives you an answer in text. It's basically a brain that can talk.
Okay, so here is the real secret sauce. Researchers took that idea and created an evolution of it, specifically for robots. It's called a vision language action model, a VLA. So it takes in all the same stuff, images, text, but it adds another layer, the robot's own physical state, like where its joints are positioned. And here's the kicker. Instead of spitting out words, it outputs physical actions.
And that right there, that's the heart of this entire revolution. It's the difference between an AI that can tell you how to fold a shirt and one that can actually guide a robot's hands to do the folding itself. We've gone from talking to doing. And that single shift is what unlocks everything in the real world.
But of course, this amazing new model creates a huge new problem. Think about it. If you want to teach an AI how to talk, well, you've got the entire internet to feed it, an almost infinite library. But where on earth do you get the data to teach a robot how to physically do things? As one researcher, Joost Tobias Springberg, puts it, figuring this out, that is the trillion-dollar question for the whole industry. And when you look at the data, the difference is, it's just staggering. For a language model, the training data is basically the entire internet. But for an action model, to teach it how to do something, that high-quality, real-world data of a robot doing complex tasks, it didn't exist. We're talking about a tiny, tiny fraction in comparison. The well was completely dry.
And yeah, it makes perfect sense when you stop and think about it, right? You can't just go scrape YouTube to teach a robot how to fold a shirt. The right kind of video from the right perspective just isn't there. So, if the data you need doesn't exist anywhere in the world, what do? You have to build an engine to create it yourself, from the ground up.
And that's exactly what companies like Physical Intelligence did. They built this brilliant solution they call a data engine. Here's how it works. First, you have human operators who control these robots remotely. They're using special arms to do all sorts of complex tasks, like making coffee or bagging groceries, and the robot just mimics their every move. Step 2. Every single one of those successful movements, every joint position, every interaction gets recorded. This creates a completely new, incredibly high-quality dataset that's never existed before. And then finally, you take that massive library of human demonstrations and use it to train the VLA model. You're literally teaching the AI to do things autonomously by showing it over and over. And the scale of this whole operation is just mind-blowing. In only 6 months, this data engine cranked out 10,000 hours of successful robot task data. Now, to put that into perspective for you, that's more than double the size of the biggest public data set that existed before this, a data set that took researchers all over the world years to put together. This is a fire hose of data compared to the slow drip they had before. And all this new data, it's been like rocket fuel for progress. Just think about this timeline. In 2023, we were just seeing the very first kind of clunky VLA concepts. They were promising, but they were starved for data.
Flash forward to mid-2024, and suddenly we have models that can do delicate, multi-step tasks like folding laundry. And now, the goalposts have already moved. The focus is shifting to what they call open-world generalization, making a robot that can go into a home it's never seen and still get the job done.
And this whole process led to a really surprising, almost counterintuitive discovery. You'd think, logically, that the best way to teach a robot to work in your kitchen is to train it over and over again in, well, your kitchen. Makes sense, right? But the data shows that's actually wrong. It turns out a model that's been trained in hundreds of different homes performs even better in your new, unseen home than a model trained only there. It's wild. That diversity of experience is not just a nice-to-have, it is the key.
So all of this is building towards a kind of holy grail for robotics. One single, universal model that can power any robot for any task. The whole idea is that the roadblock isn't the physical robot anymore. It's the intelligence, the software. And we're already seeing some pretty mind-bending proof of this. A team literally just sent their VLA model, the software, to another company that had a completely different robot, a robot the AI team had never physically seen or touched. The result? They loaded up the model, and the robot made a cup of coffee perfectly from start to finish. That's a huge deal.
You know, it's honestly hard to wrap your head around how fast this is all moving. In just a couple of years, we've gone from robots that could barely function outside a cage to these adaptable, learning machines. And it's all because of this shift to a new kind of model and the data engine that fuels it, which really just leaves us with one big final question to think about. When one single piece of software can teach pretty much any robot a brand new skill almost instantly, what's the very first thing we're going to ask them to do?